Counting on in steps of 10. I've put the place value columns here as well. At some stage numbers get so big it's no longer viable to use these, but at this stage it's absolutely fine to do this so that your child can see exactly which column they're working with. Because we're counting on in steps of 10, I've coloured the tens digits in red so that you can see exactly what's happening with the numbers. When we count in steps of 10, the units will never change, so that 7 will remain 7 however many lots of tens we add on. However, the other digits will change some of the time. Just to demonstrate this, we have the number 2487. The 8 digit is in the tens column, so when we count on in one step of 10, that's going to go up to 9 lots of 10. So we have 2497. When we add on another lot of 10, that 9 can't get any bigger because 9 is the biggest digit. That's going to go back to 0, which means the hundreds column is going to have to change. As that 10 digit changes to 0, the hundreds needs to go up 1 to 5. So adding on 10 to 2497 gives us 2507. And as we add on more tens, just the tens column will change until that goes back up where we need to change it from a 9 to a 0. Counting back in steps of 10, again the units will not change as long as we're counting back only in steps of 10. The others will change depending on how far back we count. At the moment there are 2 lots of 10. We count back in 10, we now have 1 lot of 10, and we count back another 10, we now have no tens. So currently we have 11,303. If we count back another 10, that 0 can't get any lower, so it has to go back to 9. That means that the digit in the hundreds column will also need to go down. As that tens digit changes from a 0 to a 9, the hundreds will need to go down 1 as well. So we now have 11,293, and as we count back in more steps of 10, it's just the tens column that will change down from 9 to 8, and then from 8 to 7, and so on until it goes back to 0, and then we have to take it back to 9, and the hundreds will need to go down again.